Okay, next part is DC motor. Now this is based on direct currents. So we are going to use over here direct currents, and from electrical energy we are going to get mechanical energy. Okay, in short, you remember the keyword LEM. Okay, that's LEM. This is electrical energy to mechanical energy. It means we are going to use up electricity. We are going to get mechanical energy. It means we are going to get motion out of it. Simple kind of devices that work on this DC motor principle is electric fan, mixer, grinder, washing machines. All this will be using up electricity, and we are going to get mechanical energy, that is motion out of it. Okay, now the keyword that I have given you over here is LEM, L-E-M, electrical energy to mechanical energy. This L stands for left hand rule. Okay, that is Fleming's.
The AC motor was right hand.
Yes, that was right hand. So there I am supposed to use my right hand. Okay, now here also similarly we are going to use our left hand. Okay, alright, so over here I am going to use my left hand. Same thing I am going to apply over here. Okay, father, mother, child. Father is force. Okay, so this is the direction in which the current carrying wire will be forced to move. Mother is again over here magnetic fields. So that is the direction that is going to be pointing from North Pole to South Pole inside that particular space in which the rotation is going to take place. Okay, child is the direction of current. So we are having three fingers mutually perpendicular to each other. Okay, my thumb is going to indicate F, that is father, that is F, that is force, that is the direction in which the coil will be forced to move. My first finger, okay, is going to be the direction of magnetic field, that is from North Pole to South Pole. My middle finger is going to indicate the direction in which the current is flowing through the circuit. So I'm going to consider over here the simple diagram, schematic representation of a DC motor. Okay, you can see over here there is a coiled magnets, concave shape. So these are going to give you radial magnetic fields. Then there is a source of electricity. It's a DC source, that is direct current source. This is going to make current pass through the coil which is placed inside the magnetic fields. Okay, now from this we are going to obtain the direction of rotation of the coil. Which rule I am supposed to use over here? Fleming's left hand rule. Now you can see on the screen, first of all, the direction of magnetic fields. Okay, so direction of magnetic field is this way. From front of the screen, if you see, it is from North Pole to South Pole, that is from left side it is going towards the right side. Now the direction of current. The current is, you can see the middle finger is pointing towards me. Okay, if I'm considering the part of the coil that is QP, okay, this QP, this part of the coil, the current is coming towards me. So the middle finger is pointing towards myself. What is the direction in which now the thumb is pointing? The thumb is pointing in the upward direction. So this part of the coil QP is going to experience the force which is going to be in the upward direction. Yes. Similarly, here for RS or SR, this side if I'm considering, the direction in which the current is moving is in opposite direction. So this part of the circuit, that is this part of the coil RS, is going to experience the force in the downward direction. Okay, so initially here, if I'm considering PQRS, this part of the coil, it is going to become vertical because it is experiencing that force in the clockwise direction. Once the coil becomes vertical, then obviously you can see here, these both parts, these are the split rings. These split rings are there, the coil has become exactly vertical, now there is no contact, so there is no current. But because here the coil is forced up till this point to move in the vertical direction. There is inertia of motion. Once that inertia of motion, because of that inertia of motion, the coil moves ahead. Again, it comes in contact with the part PQ which is there. It comes in contact with the split ring that is shown in part A. Again, the current will start flowing. You can apply over here again Fleming's left hand rule. You are going to obtain the direction of motion which is going to be continuous clockwise direction. So this is how continuously the coil rotates, and from electricity a continuous rotational motion is obtained, that is mechanical energy or motion is obtained.